Hello students, welcome to my channel Learn, Grow and Rise. Today we will discuss one important topic, that is ionization energy, ionization enthalpy or ionization potential. What we will discuss in this topic? We will discuss in this topic is what is ionization energy, units of ionization energy, successive ionization energy and its strength, trends of ionization energy in a period and group, and lastly we will discuss few questions in our exam decode session. But make sure before watching this video you must watch the video on atomic radius. I have given the link in my description box. Now let us define what is ionization energy. Ionization energy is defined as the minimum amount of energy required to remove the loosely bonded outermost electron from the isolated gaseous atom in the gaseous state of elements. मीन्स हमको एक गैसियस एटम से इसका आउटरमोस्ट सेल का इलेक्ट्रॉन को निकालने में जितना एनर्जी का रिक्वायरमेंट होता है, दैट इज आवर आयनाइजेशन एनर्जी. Say for example, let us take one example of the sodium. Sodium metal exists in its solid state. So we need to first convert it into its gaseous state. Why? Because we know the atoms are present far away in a gaseous state and they are loosely bonded with each other. So we need minimum amount of energy to isolate the gaseous atom, then the atom of the solid or the liquid. So what we need to do here in case of the sodium metal that is exist in the solid state, so we need to first supply the heat to convert it into its gaseous state. And we know the process is known as the sublimation, conversion of the solid sublimation. This is, what is sublimation? This is the conversion of the solid state to gaseous state directly is known as the sublimation, and the energy provided or required for this process is known as the sublimation energy or SE. Okay, so what is the electronic configuration of the sodium? Sodium electronic configuration is 11. So first, solid state of sodium, by providing the sublimation energy we change it into its gaseous state. In the gaseous state the atoms are far away from each other, so we can easily isolate one atom. Now we have only single sodium atom. इसका atomic number 11 है and the electronic configuration is 281. So one electron is present in its outermost cell. So this is the one electron that is present as the outermost cell of the sodium atom. So that is only the one electron that is present as the outermost cell in case of the sodium atom. This is the one electron. So the amount of energy required to remove this one electron, one outermost electron, is known as your ionization energy or ionization enthalpy or ionization potential. The minimum amount of energy we need to remove the outermost electron or the single electron present in the outermost cell of the sodium is known as its ionization energy. Now let us know why ionization energy can be called as a ionization potential. Because it is defined as the work done to remove the electron from the outermost cell of an isolated gaseous atom. So how we can define the ionization energy? We can also define the ionization energy as a work done, because while removing the electron we are doing some work by providing the energy. So that's why we can also call the ionization energy as the ionization potential. But as the ICSE recommendation, we can say the ionization energy as the ionization enthalpy, not the ionization potential. Why we call it is the ionization enthalpy? Because enthalpy means heat energy. You have seen in my previous example that while converting the sodium solid to sodium gaseous or converting any solid to into the gaseous state, we need to supply the heat energy, and sometimes while removing the electron also we are supplying the heat energy or the energy in the form of the heat. Hence we call the ionization energy as the ionization enthalpy. Now let us discuss the units of ionization energy. The units of ionization energy is either kilojoule per mole or electrons volts per atom or kilocalorie per mole. These are the units of your ionization energy. Now let us discuss the successive ionization energy. The energy required to remove the first outermost electron is known as the first ionization energy or first ionization potential. Say for example, let us talk about aluminium. Aluminium atomic number is 13. इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन is 283. 3 इलेक्ट्रॉन आउटरमोस्ट सेल में प्रेजेंट है. सो हमको एक एक करके निकालना है. वी कैनॉट रिमूव ऑल द 3 इलेक्ट्रॉन्स टुगेदर. सो पहला इलेक्ट्रॉन निकालने में जो एनर्जी रिक्वायर्ड होता है उसको हम फर्स्ट आयनाइजेशन एनर्जी और फर्स्ट आयनाइजेशन पोटेंशियल बोलते हैं. अभी दूसरा इलेक्ट्रॉन के लिए जो एनर्जी रिक्वायरमेंट होता है उसको हम IE2 बोलेंगे. सो द एनर्जी रिक्वायर्ड टू रिमूव द रेसिडुअल इलेक्ट्रॉन आफ्टर रिमूविंग द फर्स्ट इज नोन एज योर सक्सेसिव आयनाइजेशन एनर्जी. पहला इलेक्ट्रॉन को निकालने के बाद जो इलेक्ट्रॉन बचता है उसको सक्सेसिवली एक के बाद एक निकालने में जो एनर्जी रिक्वायर्ड होता है, जो आयनाइजेशन एनर्जी रिक्वायर्ड होता है उसको हम सक्सेसिव आयनाइजेशन एनर्जी बोलते हैं. जैसे कि यहाँ पर सेकेंड इलेक्ट्रॉन को निकालने में IE2 बोलते हैं उसको. थर्ड इलेक्ट्रॉन को निकालने में जो एनर्जी रिक्वायर्ड होता है उसको IE3 बोलते हैं. एंड फोर्थ इलेक्ट्रॉन को निकालने में जो एनर्जी रिक्वायर्ड होता है उसको IE4 ही बोलते हैं. Now let us see how the value increases. Okay, so you can see the IE4 is greater than IE3 is greater than IE2 is greater than IE1. So there is a successive increase in the ionization energy. What is the reason? The reason is that on removal of the electron, the size of the cation, because once we remove the electron, the atom converted into the cation. एंड कैटायन का साइज ग्रेजुअली डिक्रीज होता है. जब कैटायन का साइज डिक्रीज होता है, न्यूक्लियर इफेक्टिव अट्रैक्शन ऑफ न्यूक्लियस ऑन रिमेनिंग इलेक्ट्रॉन्स इंक्रीजेस, ये बढ़ जाता है. इसीलिए हमको ज्यादा अमाउंट ऑफ एनर्जी लगता है टू रिमूव द अदर इलेक्ट्रॉन्स. हेंस आयनाइजेशन एनर्जी और सक्सेसिव आयनाइजेशन एनर्जी इज इंक्रीजिंग ग्रेजुअली. नाउ लेट अस सी वन एग्जांपल ऑफ aluminium. Okay, let me draw the orbital diagram of the aluminium. This is my nucleus, this is the first cell, this is the second cell or L cell, and it is the M cell. And you can see in the M cell how many electrons are present. In the M cell 3 electrons are present. Is it clear? So L is in the M cell, 3 electrons are present. The amount of energy required to remove the first electron is known as the IE1. And what is the value? It is 580 kilojoule per mole. So first let me remove the first electron. Okay, so I have removed the first electron by providing the 580 kilojoule per mole energy. So now the atom of aluminium converted to the aluminium ion Al+1. And as we know that when the atom changes to its cation, the size of the cation gradually decreases from the parent atom. So the Al+ का size अभी decrease हो गया है. Atomic size is inversely proportional to the ionization energy. अभी ionization energy बढ़ जाएगा. तो second electron को निकालने में we need more energy than the first ionization energy. Okay, you can see the example here. The example is IE2 for Al+ ion is your 1815. So I remove now I have removed already the second electron. Now my Al+ ion become Al+2. Again more the size reduces more. As the size reduces more, why the size reduces more? Because the effective nuclear charge अभी बढ़ गया. कैसे बढ़ा ना? पहले in Al+1 में in case of the Al+1 13 प्रोटॉन था and 12 इलेक्ट्रॉन था. and in Al+2 अभी कितना इलेक्ट्रॉन हो गया? वही 13 प्रोटॉन but 11 इलेक्ट्रॉन. So as the nucleus, you can see clearly here, nuclear charge remains same but number of electrons reduces. So that effective nuclear charge on remaining electron वो क्या होता है? बढ़ जाता है. So gradually the ionization energy decreases. You can see for the I3 Al+2 से जब हम एक इलेक्ट्रॉन निकालते हैं तो एनर्जी रिक्वायर्ड इज योर IE3, देन द एनर्जी का वैल्यू यू कैन सी इट इज 2740 kilojule per mole. And after removing the third electron, now what is the configuration? Now the configuration of Al+3 will become 2,8. Is it clear? So this is the, let me remove the last electron, and as we remove the last electron, so you can see this is the last electron. Now how many cells are there? Now 2 cells are there. In 2 cells, it consists of 1, 2, 3, 4, 5, 6, 7, 8, 8 electrons. Now it is a very stable configuration, because you know when the element consists of, or atom consists of 8 electrons in its outermost cell, they become very stable. So it is very difficult to remove the electron, or it requires more amount of energy to remove the electron from such a stable configuration. And you can see the example here. Here in I3 we need 2740 kilojule per mole, but in case of the I4 we need 11,600 kilojule. Can you see how much, what is a big jump here? So it is difficult to provide such amount of energy, and also that is the reason I5, if you want to remove the 5th electron, you cannot imagine the amount of energy required. So it is very difficult to provide such a huge amount of energy. That's why I5 is not there. Okay, now let us see what are the factors affecting the ionization enthalpy or ionization energy. The first factor is your atomic size, and atomic size is inversely proportional to the ionization energy. This means when atomic size increases, ionization potential decreases. So now why it happens? Because when the atomic size increases, the distance of the electron from the nucleus increases. Okay, hence the force of attraction exerted by the nucleus also decreases. जब डिस्टेंस बढ़ जाता है इलेक्ट्रॉन के ऊपर में न्यूक्लियस का फोर्स घट जाता है. जब ये घट जाता है आयनाइजेशन एनर्जी क्या होता है, हमको लेस अमाउंट ऑफ एनर्जी चाहिए टू रिमूव दैट इलेक्ट्रॉन, हेंस द आयनाइजेशन एनर्जी आल्सो डिक्रीजेस. Now let us discuss the second factor, that is nuclear charge. जब nuclear charge is directly proportional to the ionization energy. जब nuclear charge increase होता है तब क्या होता है, your ionization energy also increase होता है. Why? Because greater the magnitude of the nuclear charge, greater the electrostatic force of attraction exerted on the nucleus and outermost electron increases. Okay, जब nuclear charge इंक्रीज होता है तब इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन ऑन द न्यूक्लियस, बाय द न्यूक्लियस ऑन द इलेक्ट्रॉन क्या होता है, इंक्रीज हो जाता है. हेंस इट इज डिफिकल्ट टू रिमूव द आउटरमोस्ट इलेक्ट्रॉन फ्रॉम एन एटम विथ अ हायर न्यूक्लियर चार्ज. हमको ज्यादा एनर्जी का जरूरत होता है वो इलेक्ट्रॉन को रिमूव करने में. Is it clear? Therefore, more amount of energy is required to remove the outer electrons, and ionization energy increases. जब न्यूक्लियर चार्ज इंक्रीज होता है तो फोर्स ऑफ अट्रैक्शन इंक्रीज होता है बाय द न्यूक्लियस ऑन द इलेक्ट्रॉन, हेंस वी नीड मोर अमाउंट ऑफ एनर्जी टू remove that type of electron, hence the ionization energy increases. Now let us discuss the trend in the ionization energy. The first in period, unmoving the period means right to left, we can say it is across the period means right to left. So ionization energy increases. Why the ionization energy increases? Here there are two dominating factors. One is the atomic size, another is the nuclear charge. When we move left to right, atomic size decreases and also nuclear charge increases. So as atomic size decreases, ionization energy increases, and as nuclear charge increases, ionization energy also increases. So on moving a period from left to right, so ionization energy increases. Let us see the example in the second period. You can see there is a gradual increase in the ionization energy from lithium to neon with few exceptions. The star marks represent the exception. What are the exceptions? Exception is beryllium, exception is nitrogen and neon. Neon is not an exception, you cannot say, but there is a very high increase of the ionization energy. Okay, so why? Due to it is a noble gas and it has a very stable configuration. Now let us discuss why boron has less ionization energy than beryllium. That is also due to the stable electronic configuration. If you see the electronic configuration for the boron is 5, so electronic configuration is your 2, 3. And in case of the beryllium is 4, the electronic configuration is 2, 2. Is it clear? So, as it is 2, 2, then you can see the 2 is the when the electron, let me write 5 here. So, we know that when the outermost shell consists of the 2 electron or 8 electron, the configuration is very stable. That is the reason beryllium possesses a higher ionization energy than that of the boron. And same thing happens with the nitrogen and the oxygen. The electronic configuration of nitrogen is stable than that of the oxygen. Hence, nitrogen possesses more ionization energy than that of your oxygen. And you will find the same trend in period 3. In period 3, magnesium ka ionization energy is greater than aluminium and your phosphorus ka ionization energy is greater than sulfur. And argon, as usual, it is a noble gas, so it has highest electronic configuration. Okay, so now discuss it is in a group. When we move down a group, here atomic size is a dominating factor, hence ionization energy decreases. As we moving down the group, atomic size increases because now new cells का एडिशन हो रहा है, नंबर ऑफ सेल, एंड ऑल्सो न्यूक्लियर चार्ज इंक्रीजेस क्योंकि एटॉमिक नंबर का इंक्रीजमेंट हो रहा है. इज इट क्लियर? सो जब एटॉमिक साइज और न्यूक्लियर चार्ज बोथ एटॉमिक साइज इंक्रीजेस जब moving down the group and nuclear charge also increases, but increase in the atomic size overcomes the effect caused by the increase in the nuclear charge. Hence, atomic size is the dominating factor. So that ionization energy follow the trend for the atomic size. As atomic size is inversely proportional to the ionization energy, जब atomic size बढ़ता है, ionization energy decrease होता है. Now let us see the example in the group 1 and group 17. In group 1, you can see lithium से cesium तक there is a number of cell. If you see the electronic configuration, number of cell increases. For lithium it is 2, then 3, then 4, then 5, then 6. Number of cell increases, and along with the nuclear charge also increases, but the effect of nuclear charge is overcome by the increase in the number of cells. Hence, it follows the atomic size trend. As we know that atomic size is inversely proportional to the ionization energy, on moving down the group, what happened? On moving down the group, the ionization energy also decreases. You can see how it decreases while moving down the group. Same thing you can see in case of your group 17. Okay, I hope. Now let us remember few important points. What are the points? The point is that in each period, the alkali metal shows the lowest ionization energy, and cesium has the lowest ionization energy in the periodic table. Why? But we are not considering the francium, because though francium is present the last element as the last element in the group 1, but we are not considering it because it is a radioactive element. So we cannot determine correct value for the ionization energy. Then in the period, noble gases shows the highest fast ionization energy. And another important point is that metal have the low value of ionization energy, whereas non-metal have the high value of ionization energy, because metal का size ज़्यादा है. Metal has a low value because it has a metal is a greater size. So greater the size, lesser the ionization energy. Hence, metal का ionization energy is greater than that of your non-metal. Is it clear, children? I hope all of you understand the topic very well. So now let us discuss few questions in the exam decode session. My first question is that which of the following has the lowest ionization energy? You can see in option all the elements belongs to second period. Now let us write the correct sequence. Nitrogen is atomic number 7, then oxygen it is 8, then fluorine it is 9, and neon it is 10. So as we know, when we move across a period or from the left to right, the ionization energy increases. So नियॉन का ionization energy highest होना चाहिए and नाइट्रोजन का lowest होना चाहिए. But there is an exception. ऑक्सीजन का ionization energy सबसे lowest होगा क्योंकि नाइट्रोजन का ionization energy is greater than oxygen due to the stable configuration. इसका जो स्टेबल कन्फिगुरेशन है इसलिए इसका स्टेबल इलेक्ट्रॉनिक कन्फिगुरेशन, हेंस नाइट्रोजन का आयनाइजेशन एनर्जी इज ग्रेटर देन दैट ऑफ द ऑक्सीजन. एंड व्हाट इज द देन ऑक्सीजन हैज द लोएस्ट आयनाइजेशन एनर्जी. सो व्हाट इज द करेक्ट आंसर? द करेक्ट आंसर इज ऑक्सीजन. नाउ which atom has the lowest first ionization energy? I will not discuss this in this session because I want that please watch my video thoroughly so that you can get the answer very well, and please write the answer in the comment section. Okay, now what is the third question? What is the ionization energy? The energy needed to gain an electron, the amount of energy in the gaseous atom, the energy needed to lose an electron from a gaseous atom, the amount of energy needed to lose an electron. So the answer is the energy needed to lose an electron from gaseous atom. So the correct option is C. Hope children, all of you like the video very much. So please do not forget to like, share and subscribe and hit the bell icon. Please watch the video till the end, and thank you.